Hello and welcome, dear students. Today we are going to discuss some important facts related to the process of dehydration of foods, its basic principle and its engineering concepts. I would like to tell you that dehydration of fruits and vegetables is one of the oldest forms of food preservation techniques known to man. Although food preservation is the primary reason for dehydration, the process offers certain other advantages, like it lowers the cost of packaging, storing and transportation of food commodities by reducing both the weight and volume of the final product. The basic concept associated with food dehydration may be understood by the help of the terms like water activity and moisture sorption isotherm. The moisture sorption isotherm is a relation between the equilibrium moisture content of a material, which is expressed as mass of water per unit mass of dry matter, and water activity at a given temperature. Water activity, on the other hand, is the amount of free water or water that is not chemically bound to the hydrophilic sites, thus being available for the microbial growth in the foods. Water activity is affected by the temperature, therefore, it can be understood that sorption isotherms are also temperature dependent. As a processing method, dehydration may be defined as a unit operation in which most of the moisture content is removed from the foods. That helps to extend their shelf life. By removing moisture content from the foods to a considerable degree, we can inhibit the growth of bacteria, yeasts and molds that normally spoil the product and can decrease its shelf life. It has a widespread application in today's market with instant beverages, soups, coffee or spices as some of the major food products that are dehydrated. During the actual process of dehydration, removal of moisture content from product is usually done by evaporation, vaporization or sublimation, employing a heat, mass and momentum transfer process within the product and between the product and the dehydration medium. Let us discuss some basic concepts associated with dehydration in detail. Some important terms that deserve priority in the discussion are moisture sorption isotherm, water activity and psychrometry. Now let us discuss moisture sorption isotherm. The moisture sorption isotherm of a food material is a curve obtained by plotting its moisture content, which is usually expressed as mass of water per unit mass of dry material versus the water activity of the vapor space surrounding the material, or the percent equilibrium relative humidity in the environment at constant temperature. According to the adsorption isotherm classification of Branier, Emmett and Teller, made in 1938, food materials usually present type 2 isotherms, which are manifested by a nonlinear sigmoidal curve, or type 3 behavior, which is manifested by a concave shape. The latter is, however, the characteristic pertaining to foods rich in soluble components. Secondly, we shall discuss water activity. The amount of water in food and agricultural products affects the quality and perishability of these products. However, perishability is not directly related to the moisture content. In fact, perishability varies greatly among products with the same moisture content. A much better indicator of perishability is the availability of water in the product to support degradation activities such as microbial action. The term water activity is widely used in the food industry as an indicator of water available in a product. The term availability of water is a measure of how freely water molecules participate in chemical reactions, or how easily water molecules diffuse to the site where chemical reaction is taking place and participate in it. Mathematically, water activity is given by the ratio of vapor pressure of water in the substance to the vapor pressure of pure water at the same temperature. The third important term related to food dehydration is psychrometry. Hot air is used both to supply the heat for evaporation and to carry away the evaporated moisture from the product. Psychrometry or hygrometry is used to describe the field of engineering concerned with the determination of the physical and thermodynamic properties of such gas vapor mixtures. In addition to this, there are a few temperature terms that need to be explained. These are dew point temperature, dry bulb temperature and wet bulb temperature. The temperature at which a given unsaturated air vapor mixture becomes saturated is called dew point temperature. Any further decrease in this temperature leads to the condensation of water from the air. The temperature measured by a dry thermometer immersed in vapor gas mixture is called dry bulb temperature, while as if the thermometer is surrounded by a wet cloth, heat is removed by the evaporation of the water of the cloth. As a result, the temperature of the thermometer falls, and this lower temperature is called wet bulb temperature. Now let us discuss the mechanism of drying. Hot dry air is used for commencing dehydration. Heat from the dry air is absorbed by the food, which provides the moisture content present in it, the latent heat of vaporization. The moisture content begins to evaporate from the surface of the food. It develops the vapor pressure gradient between the interior of the food and its exterior surface. This gradient acts as a driving force for the removal of the moisture content from the food to a greater extent. The removal of moisture from the food follows a series of drying rates, that is, constant rate period and falling rate period. Under constant drying conditions, the drying period during which evaporation rate per unit drying area remains constant is called constant rate period. Heat is transferred convectively from the warm air to the cooler wet surface through the boundary layer at the interface that induces evaporation. Constant rate period is observed in foods in which the moisture content is greater than critical moisture content. Critical moisture content is that moisture content at which the drying rate first begins to drop under constant drying conditions. Below the critical moisture content, the rate of water transfer from the interior of the product to its surface decreases continuously, decreasing the drying rate of the foods. This corresponds to the falling rate period of the food dehydration. Theoretically, drying stops, that is, the drying rate becomes zero when the moisture content everywhere in the food has been reduced to the equilibrium moisture content. Further, it is important to note that there are several factors that affect the rate of drying. These include temperature, humidity, air velocity, and the type and size of food material. The first important factor is temperature of the drying air. The higher the temperature of the drying air, more is the rate of heat transfer and more is the rate of drying. The ideal temperature for drying food is 60 to 70 degrees Celsius. The use of higher temperature, however, may lead to cooking of the food rather than drying. The second important factor is humidity. The lesser the humidity of the air, more is its capacity to carry the moisture content evaporated from the food. The third important factor is air velocity. The velocity or speed at which the hot air moves over the product to be dehydrated influences the rate of dehydration as it forms a boundary layer near the surface of the food that hampers the rate of heat as well as mass transfer. The higher the velocity of the air, smaller is the thickness of this barrier layer and lesser is the hindrance to the heat and mass transfer. The fourth important factor is the type and size of the food material. The foods with a lesser thickness of slices dry rapidly as compared to those with greater thickness. This is because in the former, moisture content takes lesser time to migrate from innermost layers towards periphery from where the evaporation occurs. Now let's discuss different methods of drying foods. Some important methods of dehydration are sun drying, bin drying, cabinet drying, tunnel drying and drum drying. First let's discuss the sun drying. Sun drying is usually used in case of fruits due to their high sugar and acid content, which makes them safe for this process. Drying the fruits on hot, dry and breezy days with a minimum temperature of 85 degrees Fahrenheit is normally optimum for this process. However, the hotter the day, the better is it for the dehydration operation. Relative humidity should be below 60%. As the weather is uncontrollable, sun drying the fruits can be risky and it can take several days to complete the process. In actual practice, prepared foods are placed on drying trays that are usually made up of stainless steel screening or a thin wood lath. The trays are placed away from dusty roads and yards and kept elevated at about 1 inch above the table with spools or bricks to allow good air circulation below the food. It is covered with a muslin or cheesecloth tent to protect from insects. Fruit is dried in direct sunlight and trays are moved periodically to ensure direct sun exposure. Secondly, we will discuss bin drying. Bin drying systems are common in on-farm grain drying operations. The bin is filled with grain and drying air is forced up through the grain from a plenum chamber beneath the perforated floor of the bin. The grain on the bottom is dried first and drying front progresses upward through the bin of grain until all grain is dried. Thirdly, we shall discuss cabinet and tunnel drying. Cabinet dryers are usually small insulated units with a heater, circulating fan and shelves to hold the product to be dried. The small dehydration units sold for home use are small scale examples of this type of dryer. On the other hand, tunnel dryers are a large scale modification of the cabinet dryer concept. The drying chamber is a tunnel with multiple carts containing trays of the product to be dried. New carts of the undried product are loaded at one end of the tunnel as carts of dried product are removed from the other end. Airflow in these dryers may be parallel or counter to the movement of carts in the tunnel. Now let us discuss drum drying. In contrast, drum drying equipment consists of large rotating drums that are used for drying slurries. A thin film of the slurry is deposited on the bottom of a rotating drum as it passes through the slurry. The slowly rotating drum is heated and sometimes held under a vacuum. The dried product is scraped from the drum before the rotating surface re-enters the slurry. There are various other drying techniques that are used for the purpose of dehydration. The major function of all such types is to move air over the product in such a manner that the product is dried as economically as possible without the damage. At the end of this presentation, I would like to tell you the effects of dehydration on foods. Dehydration leads to several changes in the food products that affect their quality. These include loss of volatiles and flavors, changes in the color and texture, decrease in nutritional value, residual enzyme activity, and microbial activity in the dried foods. These not only affect the quality but also the shelf life of the final product. Some important changes in the food article during the process of dehydration include browning reactions, which include enzymatic and non-enzymatic browning reactions. In case of fruits, vegetables, frozen and dehydrated foods, browning is an undesirable change as it results in the formation of off colors. It also lowers the nutritive value of the food article. Secondly, lipid oxidation is caused in several foods. Lipid oxidation is responsible for rancidity, development of off flavors, and the loss of fat soluble vitamins and pigments in many foods, especially when dehydrated. Thirdly, color loss. Drying changes the surface characteristics of food and hence alters the reflectivity and color. Carotenoids are fat soluble pigments present in green leaves and red and yellow vegetables. Chemical changes to carotenoid and chlorophyll pigments are caused by heat and oxidation during drying. In general, longer drying times and higher drying temperatures produce greater pigment losses. Fourthly, aroma loss. There is often decrease in the quality of the dried products because most conventional techniques use high temperatures during the drying process. Processing may also introduce undesirable changes in the appearance and will cause modification of the natural balanced flavor and color. Heat treatment of fruits and vegetables often reduces the number of original volatile flavor compounds while introducing additional volatile flavor compounds through the auto-oxidation of unsaturated fatty acids and thermal decomposition or initiation of Maillard reactions. This highly affects the sensory attributes of the dehydrated product. Another important effect of drying is the nutrient losses of the food. In fruits and vegetables, losses in nutritional attributes during preparation usually exceed those caused by the drying operation. The water-soluble vitamins can be expected to be partially oxidized and are diminished during blanching and enzyme inactivation. Last but not least, the changes are observed in the texture. Porosity may be developed by creating steam pressure within the product and a case hardening surface through rapid drying. On the other hand, as moisture is removed from fruits or vegetables, their cellular structure begins to collapse and the cells become smaller. The result of this is the shrinking of the product as it dries. This was all about the process of dehydration. I hope you have understood well. Thank you very much.